Welcome to another edition of A for A levels. This is my tutor. Good morning. Today we're going to go through mechanics. Winter paper 2020, paper 41. Let's go. Particle B of mass 5 kg is at rest on a smooth horizontal table. Particle A of mass 2.5 kg moves on the table with a speed of 6 meters per second and collides directly with B. In the collision, the two particles coalesce. Coalesce means they stick together. Find the speed of the combined particles after the collision. Okay, this is A. A move towards B. 6 meters per second. B is stationary. This is 5 kilograms. A is 2.5 kilograms. So after the collision, they stick together and move at a combined speed of V, let's say. So the combined mass is 7.5 kilograms. Using law of conservation of momentum. 2.5 kilogram times 6 meters per second. B has a momentum of 0. The final momentum is 7.5 times V. So V equals to 2 meters per second. Okay. Find the loss of kinetic energy of the system due to the collision. The final kinetic energy is half times 7.5 times 2 squared. Okay, this is the final kinetic energy. The initial kinetic energy is half times 2.5 times 6 squared minus equal 18 times 2.5, 3645 minus 2 times 7.5, 15 equals to 30 joules. That's the answer. Car of mass 1,400 kg is moving along a straight horizontal road against a resistance of magnitude 350 Newton. Find in kilowatt the rate at which the engine of the car is working when it's traveling at a constant speed of 20 meters per second. Is a resistance of magnitude 350. At a constant speed. Okay, at a constant speed means the thrust or the pulling force is equal to the resistance. So F is 350 Newton. What is FV? 350 times 20. 0.000 watts. So it must be in kilowatts. So it's 7 kilowatts. Find the acceleration of the car when its speed is 20 meters per second. And the engine is working at 15 kilowatts. So this is F equals to P over V. This is still 350 Newton. Resultant force equals to mass times acceleration. Resultant force is P over V minus 350 equal 1,400 A. This is 15,000 over 20 A equals to 1,400 A. 750. So you have 400 equals equals to 1400A. It's 2/7 meters per second square. Okay, that's your solution. Co-planar forces of magnitude 8, 12, and 10 and P Newton act at a point in the direction shown in the diagram. I like this kind of questions. Diagram is given. Find P and theta. In this type of question, you need to resolve the forces in horizontal and vertical. So vertical, P upwards is P sine theta plus 8 sine 30 equals to 10 sine 45. Sine theta. 8 sine 30 is 4. So sine 45 is 2/2. So this is 5/2 minus 4. Resolve horizontally. P cos theta plus 10 cos 45 equals to 12 8 cos 30. Okay, cos theta equals to 12. Cos 30 is 3/2 plus 4/3 minus 10 cos 45 is still the same, 5/2. Okay, question 1, question 2. 1 divide 2 will be sine theta over cos theta is tangent theta equals to 5/2 minus 4 over 12 plus 4/3 minus 5/2 theta equal. Now I'm using the exact values so that the answer that I obtain will be the best possible solution. Answer is 14.5 degrees. Okay, now if I take 1 square plus 2 square will be P sine square theta plus P cos square theta will be P square equals to 5 minus 4 square plus 4 plus 4/3 minus 5/2 square. Okay. Okay, there we have it. P equals to 12.2 Newton. Into 3 significant figures. Okay, next. Particle P moves in a straight line. It starts from rest at the point O on the line, and at time t seconds after leaving O, it has an acceleration of A, where A is 60 minus 80. This. Find the distance P before it comes to instantaneous rest. P is integrate A dt. V equals to t square minus 18t c. Starts from rest at time t equals 0. So V is 0. So C is 0. So So V equals to 3t square minus 18t. S is integrate V dt equals to t cubed minus 9t square C. When OT is 0. So S is 0, T is 0. C is 0. So S is also T cubed minus 9T squared. Now when it comes to instantaneous rest, V equals 0. So 3T squared minus 18T equals 0. 3T, T minus 6 equals 0. So T equals 0, that is when it starts, and T equals 6. So this is the time when it comes to instantaneous rest. So the displacement is 6 cubed minus 9 times 6 square. So it's 6 cubed minus 9 times 6 square. So you get a negative answer. Negative 108. So what's the question? The most before it comes to instantaneous rest. Okay. So when t is 0, v is 0. So acceleration when t is 0 is a negative acceleration. So it's moving to the left. So the distance traveled is 108 meters. Answer 108 meters. Okay. Two particles of masses 0.8 kilogram and 0.2 kilogram connected by a light inextensible string that passes over a fixed smooth pulley. The system is released from rest with both particles 0.5 meters above a horizontal floor. In the subsequent motion, the 0.2 kilogram particle does not reach the pulley. So particle will move down here, this one will move up, let's say with an acceleration of A. Mark all the forces. Tension is T. Weight is 8 here, weight is 2 here. Okay. Show that the magnitude of the accelerated particle and find the extension in the string. So on the left, system of forces is always resultant force equals to mass times acceleration. So the resultant force is 8 minus T equals to the mass 0.8A. This is the first equation. On the right hand side of the string, minus 2 equals to 0.2A. This is the second equation. Okay. Adding these two equations, 6 equals to A. So the acceleration is 6 meters per second square. Okay. Now, substituting into the second equation, T minus 2 equals to 1.2. So T equals to 3.2 Newton. That's it. When the 0.8 kilogram particle reaches the floor, it comes to rest. Find the greatest height of the 0.2 kilogram particle above the floor. Okay, so this will move 0.5 meters. This is 1 meter from the ground. Okay, so when the 0.8 kilogram reaches the floor, the string will be loose already. Okay, so what is the speed when it reaches the floor? So the initial speed is 0. This particle falls from here to here. 0.5 meters, U is 0. A is 6. Okay, so you want to find V. V square equals U square plus 2AS. V square equals 0 square plus 2 times 6 times 0.5. So V square equals to 6. V is square root of 6. So this is the speed of 0.2 particle is 0.6. So the question is, how high does it move? How much more? So over here, the initial speed is 6. When it reaches the highest point, the final speed is 0. So it is thought it is against gravity. A is minus 10. So you want to find S. So again, you use the same formula. U square will be 6 plus 2 times minus 10 S. S is 0.3 meters. So greatest height will be a 1 meter plus another 0.3 meter, total of 1.3 meter. Okay, next question. Car of maximum 1,000 of mass 1,500 kilogram is pulling a trailer of mass 750 kilogram up a straight hill of length 800 meters, inclined at an angle of arc sine 0.08 to the horizontal. This is 0.08. The resistance of the motion of car and trailer is 400 Newton and 200 Newton respectively. So this is car. This is trailer. Resistance to the car and trailer. Trailer is 200. Nice. Okay. Trailer's weight is 7,500 Newton. Car's weight is 1,000 Newton. Okay. This is angle theta equals this. Car and trailer are connected by a light rigid tow bar. This is the tension. Okay. Have speed. The car and trailer have speed of 30 meters and at the bottom of the hill and 20 meters per second at the top of the hill. Use an energy method to find the constant driving force as the car and trailer travel up the hill. So, how high? Of length 800 meters. So, gain in potential energy. So, the total mass is 2,250 times 10 times the height. This height here is 800 sine theta, which will be equals to 800 times 0.08 is 6,464. Okay, 64. Plus the work done against friction. Total friction is 600 times the distance 800 meters equals the driving force times work done by the driving force times 800 plus this is when you're doing force in the direction of motion, it's always a loss. And loss of kinetic energy 2250 30 square minus 20 square. Okay. So 800 F equals 135750 135750 F equals 161,700. Okay, that's the solution. After reaching the top of the hill, the system consisting of the car and a trailer travels along a straight level road. The driving force of the car's engine is 2,400 Newton. And the resistance to motion are unchanged. Find the acceleration of the system and the tension in the tow bar. Again, are 400 Newton. This is the tow bar. Okay, so the driving force is 2,400. Find the acceleration. So first you need to find the acceleration. Again, it's the same thing. Resultant force is mass times acceleration. Resultant force is 2,400, which is the driving force minus 600, which is the resistance, equals to the total mass is 2250 A. Okay, now using just the system of force on the trailer. Trailer. Again, is the same thing. Resultant force is mass times acceleration. This is just for the trailer. So T minus 200 equals to 750 times 0.8. So T equals okay. You have it 400 0.8. Last question. Okay. 3 points A, B, and C lie on the line of greater slope of a plane inclined at an angle 30 degrees to the horizontal. With AB 1 meter, BC 1 meter, as shown in the diagram. Particle of mass 0.2 kilogram is released from rest A and slides down the plane. Diagram is given. Part of the plane from A to B is smooth. part of the plane from B to C is rough with coefficient of friction mu between the plane and the particle. Given that mu is half root 3, find the speed of the particle at C. Okay. So you can use this is 30. Sine 30 is the height over 1. So this is 0.5. This is also 0.5. So you can use the energy method to solve. Okay. Let's look at the particle here. Up to here, what is the work done against friction? It's force, the friction times 1, mu r times 1. So r here. Weight is 2 Newton. R 2 sine 30 equals to 1. Friction is mu r, which is half root 3. Okay. Now the lost loss of potential energy is 0.2 times 10 times the height, total height 1. Equal the gain in kinetic energy plus the work done against friction. So it's half root 3 times 1. Okay. Right. So this is 1. One minus 3 over 2. Divide by 0.1. And square root the answer. V equals to 1.16 meters per second. Given instead the particle comes to rest at C, find the exact value of mu. It's the same problem again. Again in kinetic energy, 0.2. Loss in potential energy, 10 times 1. There's no gain in kinetic energy. Okay, so there's work done against friction. So it is mu r, which is just mu times 1. So mu equals to 1. It's not possible. Oh, okay, I made a mistake. Over here, this is not sine 30, this is cos 30. Okay, so this is not 1. Okay, there's always a check and balance if you make a mistake or not. So 2 times root 3, so this will be root 3. So this is half root 3 times root 3, which will be 1.5. So the friction is 1.5. So all the answers here are wrong. So this is 1.5 times 1. H. Now we have a problem, even bigger problem. The A in the top plane part of plane AB is smooth, the part of plane BC is rough. Slows down. This one 0.2 times 10 is 5. Oh, okay, correct. So this is 5. Sometimes when you do mental calculation, you make mistake. So this is 2 minus 1.5. So this is 2 minus 1.5 is 0.5. 0.5 to 0.1 is 5. So this is 5 meters per second. Okay. So coming back to here, is mu times r, which is 1.5. Times distance 1. Oh, wait, sorry. R is root 3. Again. So R is root 3. Okay. So this is 2 equals root 3 mu. So mu is 2 root 3 mu is larger than 1 here. Let's work out. Instead of using the energy, work it out another way. Let's say at B, B square equals U square plus 2AS. So it is 10 sine 30, the acceleration is 5. So V square equals to 0 plus 2 times 5 times 1. So V is square root of 10. At B, friction mu R, which is 1.5. Weight 2, this is 1. So the resulting force is 0.5. F equals to MA. Minus 0.5 equals 0.2. A is minus 2.5. V square equals U square plus 2AS. Equals to, this will be the initial speed. So it's 10 plus 2 times 2.5 times 1. So still correct, 5. So V is square root of 5. Using the same 3 mu. So using the same, I don't want to read. The force, resultant force, mu is 1 minus root 3 mu. Okay, so R is root 3. R is 3. Equals 0. Point 2A. A equals to 1 minus root 3 mu over 0.2. So it is 5 minus 5 root 3 mu. So again, your final speed is 0 equals to U square will be, it's the same thing, which is 10 plus 2A times 1. So 5 root 3 mu is 10. So this will give you a value that is larger than 1. So there's a problem with this question. So if the problem is there, then this will be a free mark because mu cannot be larger than 1. Okay, that's it. So sometimes papers have mistake. That's it for now. If you like, you can put a comment. I will send the paper over to you. Thank you. And